Okay, guys. So let's try to solve some problems on nodal analysis and super node analysis. Okay, it's very simple to understand. So he's asking find the values of V1 and V2 for the network shown below. So the network is given to us like this. This is an source of 10 amperes and connected to a branch of 1 by 4 ohm and connected to one more branch 1 by 5 ohm and one more branch of 1 by 2 ohm and a current source of 5 amperes. You can see here we need to find out, so he's asking us to find out the V1 and the unknown voltages V1 and V2. It's very simple for us. So how to apply the nodal analysis, you are very clear. Assume that this is unknown node V1, this is unknown node V2. So when you take unknown node, already I told this will act as a high potential. Current flows from high potential to low potential and mark this current as some I1. Current flows from high potential to low potential, mark this current as some I2. Okay, so with respect to this branch, current flows from high potential to low potential like this. Mark this current as some I3, and current flows from high potential to low potential, mark this current as I4. So we need to find out V1 and V2. So we are going to apply nodal analysis at node V1. So to this node V1, try to apply Kirchhoff's current. Applying nodal analysis is nothing but applying KCL. So what are the entering currents? You can see here we have one entering current, 10 amperes is entering. And what are the leaving currents? I1 is one leaving current, but the next leaving current is nothing but I2 is the another leaving current. This is one node. So coming to the second node, so apply nodal analysis at node V2. So how many entering currents are there? One entering current is there. 5 amperes is entering. What are the leaving currents? So the current is traveling from V2 to V3. So write down this current as some I3, and the current is flowing from V2 to 0. All these are of 0 potentials. So this I3 plus I4. Now you have to write down this one. So this is of directly 10 ampere. This is in current form. Just no need to write down. 10 is equal to, how to write down the current I1? Current flows from high potential to low potential. This is nothing but current is leaving, or the leaving polarity plus V1. V1 minus 0 by 1 by 4 plus, how to write down the current I2? So the current is flowing in this direction. We can write down current is leaving, what is the leaving polarity of the voltage? V1 high potential, and somewhere this is leaving. So here it is leaving. So the leaving polarity high potential minus low potential divided by R. What is that value? 1 by 5. Similarly, let's try to do it the node 2, and here you have an entering current of 5 amperes, and so the current is flowing from V2 to V1. So I can write down, how to write down I3 is high potential V2 minus V1 divided by R. What is the 1 by R value? 1 by 5 plus, how to write down I4? So how to write down this branch current? High potential minus low potential, V2 minus 0 divided by 1 by 2. So when you solve this equation, 10 is equal to 4V1 plus 5V1 minus 5V2. So this is 5 is equal to 5V2 minus 5V1 plus 2V2. So when you solve this, you are going to get 9V1 minus 5V2 is equal to 10 is the one equation. Second equation is minus 5V1 plus 7V2 is equal to 5. This will constitute second equation. Use your calculators. You can find the values of V1 as V2. to use your calculator or solve it, you're going to get the V1 as 2.5 as well as V2 and V1 as 2.5 and 2.5, both are same. So this is how to apply. Hope you can understand. So this is, you have to assume this is of high potential. Current flows from high potential to low potential. Current flows from high potential to low potential. When you take applying the nodal here, this will act as an high potential, and current flows from V2 minus V1 by R. High potential minus V2 minus 0 by R. This is what the procedure of application of nodal analysis. Let's try to solve one more problem on this nodal analysis. So this is very much important problem. The network is given to us like this. You have an 2 ohm resistor, you have an 2 ohm resistor, and you have a 1 ohm resistor, and you have one more 2 ohm resistor, and you have a negative terminal, you have positive terminal, and you have one more resistive branch here, one more resistive branch here, and again here you are going to have an negative terminal and positive terminal, and a 2 ohm here, and a 1 ohm here, and a 1 ohm here, a 2 ohm here, and a 2 ohm again here. This is of 5 volts, this is of 2 ohms, this is of 2 ohms, this is of 1 ohm, this is of 2 ohm, this is of 5 volts. So we need to find out, you see here, the voltage at this point is plus 5 volts and 0 volts. Here this is a new node. Let's mark this as some V1, and this has some V2. It's very simple to understand. So now current flows from like this. The current flows high potential to low potential in this branch. Mark this current as a I1. So current flows from high potential to low potential to this node. Mark this current as some I2. So current flows from high potential to low potential. Mark this current as some I3 from V1 to V2, and current flows in this branch also. So mark this current as some I4. Similarly, we will try to apply it node 2. So let's try to see here. So apply nodal analysis at node V1. So applying nodal analysis is nothing but applying Kirchhoff's current law. So is there any entering current as per assumption? No. And zero entering current. What are leaving currents? 1. This is one branch I1. So this is here. This will travel like this, and this will try to close it because this will reach 0 volts. So this is nothing but I1. So this is I2 branch current. This is I3 branch current, and the remaining is I4 is the next branch current. So 0 is equal to, how to write down I1? So current is leaving, what is the leaving polarity of the voltage? Plus. So V1, current is leaving, what is the leaving polarity? Minus 5 minus 0 divided by R. R is 2 plus 2, 4, plus, how to write down I2 current, the current in this branch. So high potential is how much? Current is leaving, plus V1 minus 0 divided by 1 ohm, plus, how to write down the current I3? V1 minus, so somewhere this is positive, this is negative. V1 minus V2 divided by 2. How to write down I4? The current is flowing in this branch. So V1, current is leaving. What is the leaving polarity you are going to have here? Plus. So V1 plus 2, and it is reaching here V1 plus 2 minus V2 divided by 2 plus 1 plus 1. So So this is how we are going to solve it. Similarly, we are going to apply the nodal analysis at node V2. So coming to this node, okay, already 4 currents are completed. Let's try to mark this current as some I5 from V2 to 0. This has some I6 and this has some I7. So what are the entering currents? No entering currents are there. All are leaving currents. This is I5 plus I6 plus I7. So 0 is equal to, how to write down I5? So current is leaving. What is the leaving polarity? High potential V2. And what is the leaving polarity you have here? V2 minus 2 divided by R is 2 plus 2. 2 plus 2. How to write down the current I6 in this branch? So V2 minus V1 divided by 2 plus. How to write down the current I7 in this branch? So high potential V2, the current is flowing like this, and it is leaving at the next terminal is minus. Okay, what is that voltage source? Minus 5, and somewhere it is leaving at this terminal minus V1 divided by, what are the branches connected? 1, 1, 2. Is nothing but 1 plus 1 plus 2. So the voltage at this point, the source is how much voltage? 5 volts. Here you are also you are going to get 5 volts. So when you solve these two equations using your calculator, from here you are going to get 2v1 minus 0.75, v2 is equal to 0. When you solve it, you are going to get the second equation as minus 0.75 v1 plus v2 is equal to 2.5. Use your calculator, you can solve these two equations. Then what is asked in the question, you are going to get v1 as 1.304 volts as well as v2 is equal to 3.478 volts. This is how to solve the complex problems. Having, you can see here how many currents are there: I1, I2, I3, I4. Next one, I5. So this is nothing but I5 branch, I6 and I7. So like that, the complex problems you can solve. This is very simple to write on this current. V2 minus 5 minus V1 by, like this. Okay, so we can solve it in a better fashion to understand things in a better way. So hope you're able to understand different models under nodal analysis. Now let us try to solve a problem in supernode analysis. So hope if the video is useful, please like, share and subscribe the channel and share to your friends. If you feel, give a good like and share the channel to your friends. So hope the video is useful. Thank you.